Okay, here we go. We're going to look at Lesson 4, Unit 8, Lesson 4. We're going to split it up into two parts. Today we're going to focus on one of these special parallelograms, which is a rhombus. So a parallelogram is a rhombus, but not all rhombuses are parallelograms. So let me dig into that. So a parallelogram that has 4 equal sides is a rhombus. So one way that it could look is it could look like this, where we have all 4 sides the same. Another common way that a rhombus may look like is it might look like this. However, technically, a square is also a rhombus because all 4 sides have to be equal in a rhombus. Other properties is that the diagonals are perpendicular, which again means cross at 90 degrees. And diagonals are angle bisectors. And again, bisector means cut in half. So if we look at this example, let's choose, so our diagonals are perpendicular. That means that this is going to create a right angle. So I've created a 90-degree angle with my 2 diagonals. And I also have angle bisectors, which means this angle, call it angle 1, is congruent to angle 2. Same thing up here. Call this angle 3, call this angle 4. Angle 3 is congruent to angle 4. So we're gonna have opportunities to use this knowledge to help us figure out more unknowns. So is this a rhombus, first of all? I see 4 different congruence marks. All 4 sides are the same. Yes, this is a rhombus. Find X and Y. Okay, well, again, if I know that side AB is congruent to side BC, then I'm just going to set them equal to each other. Y plus 8 equals 3y. I'm going to get my y's together and get an answer of 4 equals 4. How about y equals 4? Okay, and now if I look at this, I say, all right, I don't necessarily know if I'm just looking at my angles, because X is in an angle. I see X right here, but I do know something else over here. And so we actually, in a rhombus, these 2 angles that are across from each other are going to be the same as well. So if this angle above, where it's yellow, is 104, then that means this angle across from it also has to be 104. And remember, a 4-sided, like a quadrilateral shape, it has interior angles up to 360 degrees. So we've learned previously that there's a formula. If it's not, 4 is really common, so we kind of remember that one. But if you had a shape that had a different number of sides, you could use the formula from our previous lesson and determine that. So I know that all of these are going to add up to each other. And if this is X, then this is X. So I have 104 plus 104 plus X equals 360. That's the long way to write it. Once I have my equation set up, I'm going to look at combining like terms. And I see that I've got X plus X. I'm going to call 2X. And this is 104 plus 104. I'm going to call that same thing as multiplying by 2. So that gives me 208 plus 2X equals 360. I'm going to subtract 208 on both sides. So I'm just left with 2x equals 152. And then to get x all by itself, x equals 76. X equals 76. The diagonals of a rhombus intersect at E. Given that the measure of angle BAC, already marked, is 53 degrees, and DE equals 8, find the indicated measures. First thing I'm looking for is angle DAC. So this angle on the inside here, which if you remember our property, the diagonals are angle bisectors. So if BAC is 53, then that means DAC is also 53 degrees. AED. So if I look, let's see here, let's find AED. AED is right here. And my diagonals meet at a right angle. So I'm going to say that this is 90 degrees because my diagonals meet at a right angle. And finally, I am looking for angle ADC. So a couple ways I could try to solve this. I know that this angle was 53 degrees. So my triangle, again, triangles are only 3 sides. So triangles have a total of 180. So if I'm looking at this triangle ADE, I know it's got 180 degrees. I've used 90 and I've used 53. So let's see how much is left. 37, but that would only be this inside piece. And it said ADC, so that would be 37, and this would also be 37. So 37 times 2 is 74 degrees. That's one way to solve it. You could also have solved it like we solved this one, where we said, okay, I've got 106 up here. Maybe I'll just draw that the other way out. So again, if I just copy this figure real quick, I would say that 53 on both sides would be 106. This would be 106. And then again, this would be x and this would be x. So it would be 106 times 2 plus 2x equals 360. And again, you're going to end up getting the same answer, minus 212. 2x equals 148. And then divide by 2, and you get 74. So I just showed you 2 different ways to think about that same type of problem. But what if we want to find AE? So I always think that it's helpful to pull these, to pull out the triangles or the figures that you see from the shape. Draw them again. So triangle, so if I look at AE, this is AE right here. I know that this is a side length of 8, and it's got an angle measure of 37 degrees. So I'm just going to draw that. So I'm going to say, all right, I've got 90 degrees here. This is 8, and this is 37 degrees. I want to find AE, which AE is this side. So if I think about SOHCAHTOA, I'm going to label from my reference angle, my opposite and my adjacent. Not going to use the hypotenuse. So what uses opposite and adjacent? That's tangent. Tangent of 37 degrees equals x over 8. I want to solve for x. So I'm going to multiply both sides by 8 and get 8 tangent 37. And when I plug that in real quick, I get 6.028. So AE is 6.028.